Welcome to the Homework Hotline at Emily Griffith High School and DPS TV 22. I'm Whitney McCabe.
And I'm Becca Hendricks.
We're teachers here at Emily Griffith High School, and I've been teaching language arts for 7 years.
I've been teaching middle school math for 5 years and teaching high school math for 1 year.
Each week on Wednesdays, we're here on DPS TV Channel 22 at Emily Griffith Technical College to help you with your homework questions.
Emily Griffith High School is one of our sponsors of the broadcast each week on DPS TV 22. That's Channel 22 within the city of Denver.
Reach out to us live by calling 720-423-4980. You can call, text, email, or contact us via Twitter or Facebook with your homework questions, and we'll be happy to help you.
We know how difficult it can be to do your homework without some help, so that's why we're here to help. So please call in or Twitter or email, please. Thank you.
You can follow us on Twitter and post your questions at EG Homework, and that's the same for Facebook, at EG Homework. So, Becca, how was your day?
It was really good. It was really good.
Good.
So we had a text question over through, or actually it was an email question, and it was a math question. They wanted me to solve or help solve an equation for them. So I have that equation on my computer, and I wanted to address that. So if we could pull up my computer, will show the viewers how to solve this equation. The equation was 45 minus 2x plus 3 times the quantity of x plus 4 equals 10. And they wanted to solve for x. So if you're solving for x, an equation such as this, the goal is to get x by itself on one of the sides. When you have something like this with your 3 in your parentheses and something inside of that, what we do is we always take care of that first by using the distributive property. So I'll rewrite everything else since we're not going to take care of that yet. But we're going to go ahead and multiply the 3 times the x, which gives us 3x. And then we'll multiply the 3 times the 4, which gives us 12, positive 12. And we still have everything else was the same. So all I did in this first step was take care of the distributive property. The next step would be to combine like terms. So when we are looking at like terms, we have 45 and 12 as like terms. And then we have negative 2x and positive 3x as like terms. So we want to put both of those together so that our problem is a little bit more simple. So we have 45 and 12 put together. So 45 plus 12 is going to give us 57. And then we want to put together positive 3x and negative 2x. So when we put those together, we're left with just 1x. And then we still have it equals 10. The last step would be to get anything off of the same side that x is on in this equation. So we want to subtract 57 from both sides so that we have x by itself. And so on the left, we have x by itself, and then on the right, 10 minus 57 would give us negative 47. So now that x is by itself, we have officially solved for x. So I hope this helps. I hope this helps you solve the algebra equations, and we really appreciate your questions. So thank you very much for emailing in and asking.
All right, I actually have another text question here, and it is a language arts question. If we can show my screen, it is asking, I have the question up there, do I always put end punctuation marks inside, or end punctuation inside quotation marks? And that's a really good question because this is kind of confusing. Typically, the end punctuation always goes in. So if you can see this on my screen, I'll make it a little bit bigger. For this question in particular, if I was going to say this was asked by someone, asked him. Okay, the question mark goes inside the quotation marks because it's part of the question. Okay, and so to cite it or to quote it correctly, that's where it would go. But if you were saying something like, have you ever read the poem Mending Wall, which because it's a poem, that would go inside quotation marks. Poem titles go inside quotation marks. But the question, have you read this poem, the question mark is not part of the title of the poem. So again, if you can see my screen, you can see that I've put the question mark outside of the quotation marks. Typically, they always go inside unless it is a title and it's not part of it, part of the quote. Okay, but that's a great question, and make sure that you text in or email any more questions that you have.
Whitney, that was great. I really actually, I didn't know that. Thank you very much. That helped me too.
Good.
So
we're going to look at a Back to Basics video now that Becca did on clearing fractions.
for Back to Basics, today we're going to talk about clearing fractions. A lot of people don't For Back to Basics, today we're going to talk about clearing fractions. A lot of people don't.
Today we're going to talk about sentence fragments and complete sentences. A sentence fragment is just a group.
Back on camera 3.
All right, it looks like we're having a few technical difficulties right now. This is only our second live show, so we do appreciate your patience. We do have someone new on the set today, and it's going to be helping us with our social media. His name is Luigi, and he is one of our students here.
Hello, my name's Luigi. I'm a student at Emily Griffith, and I decided to come and help with the production of homework helpers because it's something that I'm definitely interested in. Television production, all kinds of production actually.
How long have you been a student here at Emily Griffith?
Oh, I've been a student here for almost a year now. I started last year, around March or so.
All right. Are you involved in any clubs or anything at Emily Griffith?
I'm involved in the math club and I'm involved in student council. And the math club is definitely something really cool. It's one of those cool things about Emily Griffith that we have.
Agreed. What's your favorite? What's your favorite subject?
My favorite subject, it's actually science. It's definitely science, not math. I'm sorry, Miss Hendricks.
Well, great. If we have any science questions, hopefully you can help us out with those.
Maybe so. Depends.
Our student council is doing something right now for Valentine's Day, right?
It's true.
What is that?
We're currently sending out small candygrams, which I have constantly advertised contain pure love. And what they do is you send out a small message and it has candy and a lollipop, and it's all heart-shaped, it's all pink, it's all Valentine's Day love mush stuff.
What else can you send out besides candy?
You can also send out small sodas. They're Crush sodas.
Very
We're
punny.
very punny here at Emily Griffith.
And how much do those cost?
Everything's $1.
All right, so if you wanted to send a candygram and a Crush, then it would be $2?
Yes.
And do they have a little message attached, and how does that work?
They have a small prepackaged message that we're going to come up with a list of, but of course if you wanted to send any other, shall we say, if you wanted to say something along the lines of, I love you teddy bear because you call your significant other teddy bear, because he's a great guy. You can write, I love you teddy bear. We actually had a couple, I'm not saying any names. What they did was they decided to put each half of a heart on their small message, and we'll do that for them, and they can find each other with it.
Can they send anonymous, like secret admirers?
They can definitely send anonymous. We actually had a student who said, I want my anonymous misspelled, and so he wrote it anonymous.
Nice.
So You can do that at Emily Griffith. You can misspell things without repercussions. It's not good.
All right, so what is your purpose going to be on the show?
Well, on the show, I'll be controlling social media with our social media board. If there's any question that comes in on the social media, if you tweet us a question at EG Homework, we will put it up on here and it will appear on here. If you don't want your face to appear for some reason, you can, of course, just don't put a picture up, make a fake Twitter account and tweet us a question. You can also email us a question. You can text us a question. I'll handle all of that over here.
Do we have any questions right now?
We
that
definitely
have been tweeted?
do. We have a question here from Nancy Snyder, which says, how do I find the greatest common factor for 15 and 30?
Ooh, I can answer that. All right, so if we're finding greatest common factor, then what was the numbers? 15 and 30. So we wanted to find the greatest common factor of 15 and 30. Greatest common factor, a lot of times people mix up greatest common factor and least common multiple. They are very similar, but the way that you remember them are just by the actual name of it. Greatest, meaning the largest, common, meaning something that's the same between the two, and then factor is a number that multiplies to equal another number. So if you cut to my screen, I will show you how to find the greatest common factor of two numbers. Greatest common factor. There we go. Okay, so we were finding the greatest common factors of 15 and 30. So in order to do that, we need to make sure that we have a list of all of our factors of each of both 15 and 30. I have a little kind of a graphic organizer I have my students make when they're just learning how to do factors and find factors, because the hardest part of that is to make sure that you have found them all. So what I have them do, it's almost like a little T-chart for each. Start with 1 and itself. So 1 and 15, because 1 times 15 equals 15. And then 2 doesn't work, doesn't go into 15. And then we have 3. 3 times 5 gives us 15. And then we know, well, 4 doesn't work. And so we're back to 5. And as soon as we've repeated, we know that we've got all the factors. So our list of factors for 15 were 1, 3, 5, and 15. And I like the chart and the T-chart to help find them, just because it helps you make sure that you found all of the factors of 15. So we're going to do the same for 30, because we need to find out what the common factors are. So we need the factors of 30. So we have 1 and 30. 2, we know 2 goes into 30 because 30 is even. So 2 times 15. 3 goes into 30. 3 times 10. 4 does not go into 30. Then we have 5, and 5 times 6 gives us 30, and we've gotten to the point where we are repeating factors. So now we know that we have them all. So we're going to make a list of our factors of 30. So 1, 2, 3, 5, 6, 10, 15, and 30. Now, like I said, I apologize for the mess, but like I said, so greatest common factor is just that. It's the largest number that is the same on both lists. So I always start with my longest list, or my largest number, and I start from the highest number and work my way down. So 30, no, it's not on my list for 15, so that's not my greatest common factor. And then I get to 15. Oh, great, 15, it's on both lists. So because it's the largest number that's on both lists, that is the greatest common factor of 15 and 30. So I hope that helps a little bit explain, and I hope that the T-chart trick helps you a little bit with finding all of your factors.
All right, there is another text question. It's a math question. I don't know if you can find it, but I will read it to you. It just says, when do 2 negative numbers equal a positive?
Oh, 2 negative numbers equal positive. Well,
I thought it was they always did, but
Oh,
maybe
they
that's
always
not.
equal to positive?
Well, that's what I thought, but maybe I'm wrong.
What it depends on is the operation that you're using. So if you're multiplying, that is the case. So for example, if we had -3 times -2, and I'm putting this up on my computer just so you have a little bit of a visual. When we're multiplying, two negatives are always going to give us a positive number. When we add them, though, so -3 plus -2, we still end up with a negative. And that's because if we're looking at the number line, if I'm starting at -3, so here's my 0, -1, -2, -3, -4, and so on. If I'm starting at -3 and then I'm adding a negative number, I'm going again in the same direction that I was before. So then I move 2 spaces to the left there, and I'm at -5. So a negative and a negative only equal a positive if you're multiplying, or the inverse of that, dividing. So if I did -6 divided by -2, I'll get a +3. Hope that answers that question.
Yeah, I think it did, at least for me. So when you do email or text us in your questions, we will address them on the air, and then if we can, we'll also try to reply to you by typing back if you can't catch the show. But we are also running our broadcasts on YouTube at Denver DPS TV. So if you can't catch it from 4 to 5 on Wednesdays, you can always catch it at a different time on DPS TV, but also on YouTube. So please feel free to call in, text in, email, tweet, and Facebook anytime.
Do we have any other questions on our board?
None at all.
Okay, well in that case, let's go ahead and look at the back to basics that we were going to look at earlier on clearing fractions. For back to basics, today we're going to talk about clearing fractions. A lot of people don't like fractions, or a lot of times I've noticed that students get a little bit scared whenever they come across a problem with fractions that they might know how to do if there weren't any fractions in it. So I have this little trick that I teach my students about how to clear fractions or to get rid of them so that you don't have to work with fractions in algebra equations. So the trick is as simple as this. You're multiplying your entire equation by the least common denominator. So for example, if I had this equation here, if I wanted to get rid of the fractions 3/2 and 1/2, what I would do is I'd multiply my entire equation by 2, or the common denominator. And so what happens when I multiply my entire equation by this 2, I end up with 2y equals, and then what happens when I take 2 times 3/2, so I'll just show you over here this one, 2 or 2 over 1, same thing, times 3/2, so we get 6/2, which is the same thing as 3, so 3x, and then when I take 2 times -1/2, I get -1. And so then we end up having an equivalent equation that is nicer to work with because we have whole numbers and integers versus fractions. So it cleared the fraction. Another example I have down below is if we have denominators that are not the same, but we have 2 different fractions in our problem. So if you look at this, we have 2 as a denominator and 4 as a denominator. So the question is, well, what do I multiply by? Do I multiply by 2 or by 4? Well, you want to use the least common denominator. If you were to add these 2 fractions together, you'd have to change your denominators to the least common denominator, which is going to be 4. It needs to be a number that both your denominators can go into. So we'll multiply everything by 4, and we end up getting 4y equals negative, and I'll show you over here. So we have 4 over 1 times -3 over 2, which is -12 over 2, which equals -6. So we have -6x minus, and then if you take 4 times -1/4, you get -1. So you have a nice equation to work with that do not have fractions.
5.
All right, that was a great video.
We wanted to thank Cassandra from Emily Griffith High School for calling in last week, and also congratulate her for winning a, what is it, Chipotle card?
I think
It's not
so.
a Chipotle card, gift card. So just keep in mind also, if you're calling in and asking questions, also tweeting and emailing, you get entered to win a gift card, Chipotle gift card, or other gifts or other prizes. So keep that in mind, please.
Awesome. All right, so I'm going to do a little kind of live back to basics lesson on poetry analysis. So if we can see my computer screen, what I've got pulled up here. If you're ever asked to analyze a poem, one good tip for doing this is what we call TPcast. You may have heard of this, you may not, but I'm going to keep this up on the screen so that you can maybe write this down if you want to. So any poem that you've got, if it's on a standardized test, on an AP test, or just regular homework, if you're asked to analyze it, that term might be a little broad for you. So one thing you might want to do is break down the poem. And if you can remember TPcast, then you can remember how to break this down. You start with the title, and what I always tell my students is this is one chance where you can judge a book by its cover or by its title. So you read the poem's title first without thinking or reading anything in the poem, and you think about what you think the poem's going to be about just based on the title. So you write down your general first thoughts. Then read the poem and move on to paraphrasing it. When you paraphrase something, you put it into your own words. So let's say it's a 5-stanza long poem. You might want to have about 5 sentences that put the poem into your own words. This helps you to really understand what the poem is about whenever you put it into your own words. So the next thing is to look for words that have a deeper meaning. Connotation is the deeper figurative meaning of the word. So a word like light has a deeper meaning. It's not the denotation that you're looking for. This is not TP-dast, it's TP-cast. But I want to point out that you're not looking for the dictionary definition of the word. So if you saw the word light in a poem, you're not going to say something that illuminates the room, okay? There's a deeper meaning to the word light. When people say, I saw the light, they don't mean they saw a light bulb, okay? They are actually saying that they have had an epiphany or an awakening, or they've been enlightened, or it can be various things. Also, the word cold. The dictionary definition, the denotation of cold is just not hot. But if we say that someone is acting cold, then they might be heartless or mean or not loving. There's always a deeper meaning, a connotation to almost all words, a meaning that you're not going to find in the dictionary. So if you pick out a few words, again, if we're looking at a 5-stanza poem, you should be able to find about 5 words that have a deeper meaning. Poets love to use figurative language. The A stands for attitude. You're looking for the speaker's attitude, not the poet's, because you probably don't know what he or she was thinking, but the attitude or the mood or tone that you're getting as you're reading this poem. The next part is a shift, and while you may not think there was a shift in the poem, there typically is. It might be in meter, it could be in tone, it could be in the way that the words have been organized. Maybe a writer started off with really great grammar and then they used their poetic license to change it up a bit. There's almost always a shift, and when you find this shift, you need to explain why it's a shift. Because the great thing about language arts is that you have a lot of room for interpretation. And if you can back up your opinions with facts and evidence, then you're most likely going to get the answer right. The next part, you'll see the word title again. That's our second to last T. Now that you've read the poem, you should know what the title means. You may be able to say, oh, I was right when I first looked at the title, or maybe now you were wrong, and now you know what the title really means and how it applies to the poem. And the last T is the theme. Theme is the central message. I always like to explain it as the moral of the story because it's not what the poem's about, okay? It's the central idea. Things like love conquers all or money can't buy happiness, a very kind of general central idea that can apply to various other works. You could have a poem, a novel, and a movie that all have the same theme. So it can't be exactly what the poem's about, it's more of the central message. So if you can remember this TPcast formula, you have a really good strategy for analyzing poems. So hopefully you were able to get something out of that, or maybe write it down. And if you have any further questions about poetry analysis or figurative language or literary terms, please feel free to call in or text in, and I'll be happy to answer those questions for you.
Thank you very much. Let's look at our social media board. Luigi, do we have anything coming in?
We do, actually. We have a question from Jared at Math is Hard for Me, which asks, do you have any tricks to understanding word math problems?
Oh, well, I definitely have some tricks. It kind of depends on what the problem is. The biggest key to it is looking for kind of keywords, and I'm going to pull up a list to see, to show you some keywords of what to look for, to try to figure out what it is that question is asking. And that's really probably the first thing that you should do whenever you're reading a math problem and you're trying to figure out what to do, is ask yourself, what is this asking me to do? What is this asking me to find out? And so once you go from there, a lot of times that might even answer the question of where do I start. But I'm going to pull up some keywords and phrases that can give you some big clues in order to tell you what it is that you are going to do. So if you cut to my screen, I've got some words up on there. So addition words are things like, obviously, add, but then all together, if they're asking you to find a total of something, or a sum, or in all, these are all things that typically mean that you're going to add. When it comes to subtracting, difference is the biggest. If you're finding how much more something is than the other thing, how much is left, how much remains, or how many more, or how far is it between these two things, then subtraction is usually the case. A lot of times with multiplication, you can see on my screen that if you are doing something multiple times, or if you are doing a rate, a lot of time it could be multiplication. Division, the big keyword with division is each. So if you're trying to find something for one thing or for each, so how much does each cost, that would be division. But keywords is also a big thing to know whenever you're working on word problems, is to figure out, well, what is it asking me? A lot of times it is just decoding and translating the English words into math words. So hope that helps a little bit. Math word problems can definitely be tricky, for sure. So.
Yeah.
Oh, we've got a text coming in, I think. Luigi, what's going on over there?
That one right there, the past participle, below. Below. Past participle. Mm-hmm.
We have a question here that says, what is a past participle?
Okay, so there are various past participle verbs, okay? It's the past tense, past the past tense, okay? If you actually can pull up my computer screen here, you can see I've got a small list of some. You can see the base form of the verb, the past tense, and then the past participle. And one trick or tip to remember past participles, they're always going to have, has, or had before them, okay? So I have written a book. She has climbed the mountain. He has slept for hours. We had chosen the wrong one. Just kind of going through those. You're going to know if it's a past participle if it has that helping verb, has, had, or has. And actually later in our broadcast, I will be doing a Back to Basics video with some irregular verbs that go through some of this past participle stuff, and even another one later on with the words sit and set, trying to remember the difference between those two, but I also address the past participle form there. But if you see the word has, had, or had in the sentence, you know you're going to use that past participle form. And if you, again, can see the small image that I've got up here with just a few different kinds of past participle tenses, you might be able to kind of remember how that's supposed to work. All right? So thanks for that question.
Luigi, do we have anything else on
We
our
do.
social media board?
We have a math question that's kind of interesting. It says, there are 7 girls in a bus. Each girl has 7 backpacks. In each backpack, there are 7 big cats. For every big cat, there are 7 little cats. Question, how many legs are on the bus?
Oh, I love this question. This is a really good question. Okay, so, and this kind of goes with our word problems that I was just talking to you about. It's important for us to decode what is it asking us to do. And the question actually, I'm going to ask Luigi, I might have to have you reread that question one more time just to make sure I have all of the information for that question. However, that is the first thing, is we've got to find out how many legs are on the bus. And so that will be something to consider when we're kind of sorting this out. So we start out, there are 7 girls. Is this the truth?
Yes.
Okay, so 7 girls on the bus. What else is on the bus? Read it one more time.
Each girl has 7 backpacks.
Okay, so 7 backpacks per girl.
In each backpack, there are 7 big cats.
Okay, so per girl. And then I have
And then,
7 cats in each backpack?
yes.
Okay. Okay.
And then for each big cat, there are 7 little cats.
Oh my goodness.
And I'm assuming they are all perfectly healthy.
If they fit in the backpacks, I'm not really sure. So it's quite a full bus.
They can be plastic cats.
Might be quite a smelly bus too. So 7 kittens for each large kitten.
Yes.
Okay. And then we need to know how many legs. All right, so we've got all of our information. We've got 7 girls, 7 backpacks per girl, 7 cats in each backpack, 7 kittens for each large. And we need to know the legs. So we'll just start with, let's first find out, we've got 7 girls and 7 backpacks per girl. So let's find out how many backpacks we have all together. So if we have 7 backpacks per girl, we're going to take 7 times 7 to give us this 49, and that's how many backpacks we have. So we have 49 backpacks. So now we're going to fill these backpacks with cats. So that means that we have 7 cats in each backpack, so we're going to take that 49 and multiply by 7 again. And so I'm just going to do this on our calculator to be quick, but we have 343, and that's big cats. So then we have 7 kittens for each large cat. So we're going to take that 343 times 7 to give us how many kittens we have as well. So 343 times 7, just to be quick here. So we have 2,401 kittens. Okay, so at this point we have all of our information. We know how many animals and people are on the bus. Now we have to figure out how many legs we have. So we'll start with our girls, and we know humans only have 2 legs each. So with our girls, we know that to find our number of legs, we have 7 times 2, which is going to give us 14 legs. And then we know backpacks, they don't have legs, so we don't need to worry about that. Also, we've got 343 big cats in our backpacks. So we're going to take our 343, and we know that cats have 4 legs. So we're going to take 343 times 4 to find our big cat legs, which is going to give us 1,372. And then we have to find our kittens. And we know, again, kittens have 4 legs. So we'll take our 2,401 for our kittens times 4 for each of their legs and get 9,604. So at this point, we have 14 legs for the girls. And I'm going to write these down here. So 14 legs for the girls, 1,372 legs for the big cats, and 9,604 legs for the kittens. And so we want to put those all together so that we can find out how many legs there are all together. So when we add these up, we end up getting a total of 10,990 legs, which is a whole lot of legs to fit in one bus. But I still really liked that problem. So thank you for calling that one in. I really liked solving that one for you. Thank you. How are we doing on any other social media questions do we have
another
going?
one. Yeah.
We definitely do. We have a question here from Mark who says, "Hi, how do I make a parenthetical citation in an essay?"
All right. So I am actually in the process of writing out a few sample works cited entries so that we can kind of talk about these. So hold on just a second. I'm just trying to make some entries here. All right. Let's do 20. Okay, so if you can actually, if we can see my computer screen here. I'm going to show you some examples of works cited entries because you've got to have your works cited entries complete before you can start doing your parenthetical citations. So just to kind of quickly talk to you about how you want to come up with these. Whenever you are researching a topic, make sure that you're keeping a list of all of your sites that you're using, websites or other sources. Nowadays we can use mostly internet sites, so that you don't get yourself in a predicament by not keeping track of these things. I would always recommend that if you are using something online, print it and print it right from the source. Don't do a copy and paste, because when you print it right from the web page, you're going to get the great information at the bottom that shows the date that you accessed it, which is very important to add to your works cited entry. You're also going to have typically the publishing information, the date it was published, all of those things. And if it's missing any of that, it may not be a credible source, but that's something we can talk about later. If again, I know we were just on my screen. If you can look at my screen again, because I did these quickly, these aren't exactly in correct works cited format. You would want to indent your second and subsequent lines of each entry. But this is a good way to show you the word or phrase that you would put into your parenthetical citation. So if you had a sentence or a quote or some information, anything paraphrased, anything word for word that you get from another source that's not your own brain, has to be cited. You cite it at the end of your paper on your works cited, and you cite it parenthetically in the essay. So let's say we have a quote from this Library of Congress Afghanistan country study. That's my first link on my computer screen. What you would put in parentheses, and I'll do it down here at the bottom, is going to be the first word of the entry, which here is United. And that is also, doesn't have a page number, it doesn't look like. But if there was a page number, it would go right in there. So let's just say it was on page 9. It goes in parentheses. And then at the very end goes your punctuation mark. Okay, I'll make this a little bit bigger for you. For some reason, it's not very big. Punctuation always goes at the end. So if you had a quote, blah, 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 quotation marks, and the punctuation goes at the end. So there was a question earlier in today's broadcast about when punctuation marks are not enclosed in quotation marks. This would be another example. If you're doing a parenthetical citation, the period goes at the end of the parentheses. If we were going to cite in the paper this Jane Kirtley, notice that Kirtley is the very first word of our entry. So you would have your quote or paraphrase. Again, if you can see my screen, I'm just kind of playing with this. Paraphrases aren't going to be in quotation marks, but you still got it from Jane Kirtley. She's the first word of the entry, so that is what goes in the parentheses. That's how you would do the parenthetical citation for that. Same thing with if you were quoting something or citing something from Ray Bradbury's Fahrenheit 451, personal favorite. You would have the quote here, something about Montauk doing something, and you would have Bradbury in the quotation marks. This is a book, so there definitely are page numbers. So you would put his last name, a space, the page number, no PG, no P, no number sign, no nothing. That's exactly what it would look like if you can see my computer screen right there. The author's last name, which is the first word of the entry, the page number, end parentheses, and a period at the end. So I hope that helped you out with that question. If you have any specific questions about what you are citing for your own paper, please feel free to email us or call us with that question. But thanks very much for that, Mark.
All right, thank you, Whitney. Let's go to Luigi again and see what is going on with our social media board.
Yet again, we have another question here for Ms. McCabe. Can you explain what I need to put in the opening paragraph of a persuasive paper?
Okay, so this is pretty much standard. We don't need to see my computer screen for this. Any essay that you're writing, your introduction should introduce your paper and your topic. Some of the tips that I use, especially if you're going to be writing a pretty good essay, each paragraph should have at least 5 sentences. So we can kind of break it down like this. Every time you write an essay, the introductory paragraph, the very first sentence needs to grab our attention. It's the very first thing that your teacher or your peer editors are going to read. You kind of think about it as a speech too, because you might be giving a persuasive speech. You could write it out in essay form first. So you want to grab the audience's attention with the very first sentence. Grab our attention by asking us a question, giving us something to start thinking about. It could be any kind of attention grabber, and there are various ways to do this. Your second, third, and fourth sentences, after you've grabbed our attention, should talk about the main points in your paper. If you're doing a 5-paragraph essay, you're going to have 3 body paragraphs. If you're doing a persuasive essay, you're going to have 3 arguments that are going to persuade us to follow what you're trying to get us to do or persuade us to do. So your second, third, and fourth sentences could be your main arguments, okay? Grab our attention, then tell us what your main arguments are going to be. The very last sentence of your persuasive essay's introduction should be your thesis statement. And remember, a good thesis statement is going to have a couple of different sides that can be addressed through your arguments, and it should be fairly short. So a thesis statement for a persuasive essay on who was a better president from Abraham Lincoln or John F. Kennedy, your thesis statement might be something like, John F. Kennedy was a better president than Abraham Lincoln. And that's it. You don't want to have any because those are actually going to be your arguments. He was a better president because A, B, and C, your main arguments. So in your introduction to your persuasive essay, grab our attention, tell us what you're going to say in your 3 arguments, and end with your thesis statement, and you should have a pretty good introductory paragraph. So thanks for that question.
Thanks, Whitney. Let's go to a Back to Basics video on fragment sentences.
Today we're going to talk about sentence fragments and complete sentences. A sentence fragment is just a group of words that is only a part of a sentence, and it does not express a complete thought. So if someone walked into the room and said a sentence fragment, you would not know what they were talking about. Whereas a sentence is a group of words that contains a subject and a verb, and it expresses a complete thought. So again, if someone came in the room and said a complete sentence, you would have some idea what they were talking about. So I've got some examples here of fragments and how you can make them into sentences. This first fragment just says, ends the professional baseball season. So if someone walked in the room and just said, ends the professional baseball season, you might ask, what? What ends the professional baseball season? You can make it a complete sentence by giving it a subject, okay? The World Series is the subject, and ends is the verb. The World Series ends the professional baseball season. Another fragment here is just, is 3,500 miles long. If someone came in the room and said that, you wouldn't know what they were talking about. But we add a subject, the Amazon River is over 3,500 miles long, and now it expresses a complete thought. So here's an example here. Shannon most enjoyed the music of the bands. We have a subject, Shannon, we have a verb, most, and that is a complete sentence. George added his name to the petition. We have a subject, George, we have a verb, added, that makes it a complete sentence. The third one, Leona and another woman in the family, there's no verb. And you probably were asking, what? What did they do? Leona and another woman in the family. You would have to add more there, so that is a fragment. If you see on your papers your teacher writing the word F-R-A-G, they're not misspelling the word frog. It really is, they're telling you that it's a fragment and doesn't make any sense. This fourth one, have been designed by Van Gogh. You're probably asking what has been designed by Van Gogh. So that is also a fragment. This fifth one, I quickly put on my helmet. We have a subject, I, we have a verb, put, and so that is a complete sentence. So hopefully this helps you remember how to write complete sentences and how to not write fragments in your essays.
Thank you, Whitney. That was really great.
Thanks. I hope that that helps. If you have any questions about run-on sentences or fragments, please call in.
I think we might have another question on the media board. Luigi, what's going on over there?
Well, yet again, from the person who has no respect for cats, we have a question that reads, you have 2 pails, one that will hold 4 liters and one that will hold 9 liters. There are no markings on either pail to indicate smaller quantities. How can you measure out exactly 6 liters of water using these 2 pails? There's an unlimited supply of water.
Okay. I like that question too. That's a very good question. So you're trying to measure out 6 liters. You have a 9-liter pail and you have a 4-liter pail. The first thing that you could do is you could fill up the 9-liter pail and then dump the contents of that into the 4-liter pail. And so when you do that, you end up having 5 liters left in that 9-liter pail. So you can take that 5 liters and we have that at that point. You can go ahead and put it aside and put it in wherever it is that you're putting it. So now at this point, we've got 5 liters. We know for sure we need to get 1 liter from the 4-liter pail and the 9-liter pail to add to our 5 that we already have. So what we can do to do this is take our 9-liter pail and fill it up again, pour it into the 4-liter pail. We have 5 in there left. Dump out the 4-liter pail, take the 9-liter pail, fill up 4 again. And so at this point, there's 1 liter left in the 9-liter pail. And from that, then we can add it to the 5 liters that we already had from the original time that we dumped out that 5 liters. So as long as you can dump the water elsewhere while you're measuring, that's the way to do it. So, all right. Well, let's go ahead to go to another back to basics. We'll go and look at a episode on clearing decimals. Last time I talked about clearing fractions out of algebra equations. Another thing that sometimes my students will notice in an equation and they automatically get scared and think, oh my gosh, I can't do that, is when they see decimals. So I'm going to teach you a way to clear or get rid of decimals in an equation, so maybe it might be easier to work with. It's the same idea as clearing fractions, where you're going to multiply your entire equation by the least common denominator. Well, you might ask, well, what's the denominator? We have decimals. Well, when you think of a decimal, here's our decimal point. Whatever number is to the right of the decimal, this is the tenths place. And that means just that. It's this number out of 10. So if we were thinking of a fraction, so let's say this is 3, this would be equal to 3/10. The place value next to that is called the hundredths place. And same idea, it's however many out of 100. So if I had a 2 here, this is saying 32 hundredths. So whenever you're thinking of your least common denominator for your equation to get rid of these decimals, you want to look at the greatest, or actually the least, place value that you have here. Here we have tenths, here we have hundredths. So our common denominator is going to be 100. So that means we're going to multiply our entire equation by 100, and that will clear our decimals. So we have 100 times y, so that's 100y. And be sure to do your entire equation, not just the decimal you want to get rid of. That's a common mistake that people make. If you have to multiply your entire equation to keep it equal. Then we'll multiply this by 100. And when you multiply a decimal by 100, you are moving that decimal point to the right twice. So we end up getting 420x plus, and then we'll move our decimal over twice, 108. So here, although your numbers are large, you don't have any scary decimals to work with in your equation, so you've gotten rid of those.
All right, that was a great Back to Basics video, and we are going to look at another tweet now.
This one from the man with the awesome picture is, what is a simile?
All right, so this is a literary term that is pretty basic. It gets a little more confusing as time goes on, but it's a type of figurative language that it compares two things using like or as. So it's very similar to a metaphor, but it will always have the word like or as attached to it. So similes really allow an author to emphasize a certain characteristic by comparing an object to something unrelated. And so I've actually pulled up a poem that has a simile in it. So if we can see my computer screen. This is a poem called Robin Hood and Alan a Dale. And so it basically says here that with that came in a wealthy knight, which was both grave and old, and after him a finicking lass did shine like glistening gold. So what they're saying here in this poem is they're comparing this lass, which is a girl, to glistening gold. So it's not really saying that she literally glistened like gold, but it's comparing her to gold, her beauty, her radiance, her purity, all things associated with gold. So again, if I said something like, the little girl flitted around like a butterfly, she's not a winged insect, okay? But the gracefulness or the playfulness that a butterfly would have, I'm comparing this small child to a butterfly. So similes use like or as to compare similar, or actually two unlike things. So I hope that helped. And I think we actually have another tweet.
We have another tweet which asks, my question is, how do you graph y is greater than the absolute value of x plus 5 minus 3?
Awesome. All right, I will be happy to answer your question. I love graphing. I love everything algebra. So if you cut to my screen, I will show you how to do that. I have, forgive my kind of squiggly graph there, but That'll do the trick at least. When you are graphing absolute values, we know that our parent function for absolute values, or for something like this inequality that's given here, is the absolute value of x. The graph of that is the shape of a V with slopes of 1 and -1 on either side. So we're going to use that parent function to help us find the boundary of y is greater than the absolute value of x plus 5 minus 3. The plus 5 is telling us about a horizontal translation, saying that we're going to translate this graph to the left 5 spaces, and the -3 or the -3 is telling us about that we're going to move the graph down 3 spots. So we're going to start with our vertex. I'm going to count over 1, 2, 3, 4, 5. Here's -5, and then down 3. So here's where our vertex is going to be. And then we're going to graph absolute value just how it normally would look with that slope of 1. And then on the other side, -1. And then one thing that I didn't do is consider my greater than and less than. Because this says greater than and not greater than or equal to, we want to make sure that our boundary line is actually a soft boundary. So it's a dashed line rather than a solid line. If it were equal to, we would put a solid line. Now the last part about this is we have to get our shading down. And so to get our shading down, we look at what is actually greater than or less than. So our y is going to be greater than this boundary line that we just made. And so because of that, we are going to shade above that line. Let's see if I can get this here. So you cut to my computer screen and you can see it. So you would shade above that boundary line because y is going to be greater than this boundary line. So I hope that helps a little bit. And thank you so much for calling in that question. We really appreciate your questions. So it seems that this is about it. Our time is up for today. So we wanted to thank you again for calling and tweeting and texting and emailing. We really appreciate that. And be sure to tune in again anytime that you need homework help. We'll be here every Wednesday from 4 to 5 p.m. on DPS TV channel 22. So yeah, we'll see you next week.
Thanks.